All right, welcome to a basic electronics episode of Warmaster's Workshop. This is a tutorial series that I'm going to be doing right now just on basics, how we do things like wiring up electronics, making plastic or Sintra armor, um, basic painting, that kind of thing. These are just going to be very basic and just to kind of get you on your feet and welcome to the series. I think you'll enjoy this. Any questions that you may have um, after you've watched this tutorial, feel free to send me a message on Facebook, or you can email me at mandalore@mandalorianmercs.com. And I'm pretty good about answering your questions. I always try to get to those as soon as humanly possible. So anyway, let's go ahead and get started. What we're going to do today is I'm going to show you how to wire up LEDs, which are light emitting diodes. Um, these are different colors. One of these is orange and the other one is green. I actually scavenged these out of an old computer, um, which you'll find I do a lot of that. I do a lot of scavenging. It's kind of how they did it in Star Wars, and I'm a big fan of doing it in a similar way. So anyway, we're going to make these two little LED lights light up. LED, again, it stands for light emitting diode. Basically, what it is that one side is called the cathode and the other side is called the anode. And as electricity flows through these from one side to the other, it heats up, it causes light. Okay, it emits photons, which are light particles. So there's our LEDs. I've got just the simple ingredients laid out here, so I'll go over all of those with you. So here we have our LEDs. Um, I went ahead and found the positive and negative and have just pre-twisted those together. You'll want to do that. I would just use like a 1.5 volt battery to test it, like a AA or a AAA. Anything more than that, if you're not sure what the voltage is on these, um, you may burn them out. So you don't want to do that. So just use a AA or a AAA to find out which side of the wire is positive and which side is negative. A lot of times, if you've got a grouping like this, and most of the time it's going to be black and red, black being negative and red being positive. In this case, it's black and white, which are negative, and green and yellow, which are positive. So moving on, I've got a battery here. Now, this is a special type of battery called a lithium ion that I've scavenged several of these from laptop power supplies, and they're still good. I have a recharger specifically for these. Um, we'll go over that in a later video on how to scavenge these from a laptop battery. Anyway, we use this. This actually holds about 4.25 volts at 2200 milliamp hours, which means it pushes those 4.2 volts for a pretty long time. Um, you can. There's plenty of calculators online where you can do the math to find out exactly how long it lasts. But it's going to last a real long time considering these two LEDs are not going to use 4.2 volts. Um, and then we have, of course, our wire. I like to try to keep the traditional red equals positive and black equals negative. Um, you can get your wire from anywhere. Again, I scavenge it, so I've got lots of scavenged wires laying around. Just a standard locking switch. This is a push button locking switch. You can use any kind of switch. You can use a standard rocker switch as well if you want to use that. You don't even have to use a switch if you don't feel like it. If you just want to be able to plug it in, and when you plug it in, it's on. Um, I don't really particularly like that method because you don't really have much control um, over changing the battery or anything like that. I mean, it is super simple, but I always like having a switch in, and you want to make sure it's a locking switch for this particular application. Okay. And then, of course, for tools, we've got, oh, one more thing here. We've got our resistor for 4.2 volts. In order to drop the voltage appropriately for these LEDs, which you've got a green LED and a yellow or an orange LED. There are the best advice I can give you there to see exactly what the voltage, the forward maximum forward voltage is for an LED. There are plenty of online charts. Just Google LED forward voltage, and you will find a ton of different charts. What I will say is that greens and blues usually have the highest voltage tolerance. Um, Everything below that, it starts to drop precipitously all the way down to, I think some reds even go down to like the upper 2 voltage range, like 2.8 volts. And a lot of that is because of the heat inside. Blue always is hotter. It can take more volts. Um, that's, think about it in wavelengths and space, all that kind of stuff. Blue is always hotter than red, that kind of thing. So blue takes more voltage, red takes less. So we're going to use this. I don't know if you can see it. I'll bring it up to the camera. Maybe it'll autofocus, but probably not. Actually, let me just bring it down. Okay, now as you can see, the bands on this, which are right here, the resistor you're going to want to step down 4.25, and this will also work. This should also appropriately step down 3 AA's or 3 AA's, because those are 1.5 volts each, which equals 4.5 volts when you put them all together. So this should step down 4.5 and below appropriately. This is a 1 ohm resistor. It's brown, black, black. You always read it from. I've got it backwards, which is good for here for what you guys are seeing. You always start from, would be this side. You always start from the left and go to the right. That's the way I look at it. Or top and going down to the bottom. Either way, it's brown, black, black. And then the bottom one here is just a tolerance. Okay, this one is gold. Some are silver. Sometimes they'll have other colors as well. Usually you'll see gold or silver. But this one is gold, so it's brown, black, black. That's 1 ohm. Tolerance really doesn't matter in this application, since we're not talking about super high current values. So there's the resistor we're going to need. All right, now we've got our battery again right here. Now for our tools, this is pretty easy. Okay, we've got just some tweezers. I like to use. Oh, let me unzoom here, or zoom back out. All right, so we've got some tweezers. I like to use tweezers. They always come in handy, especially for these little ends of the wires here. That makes it easier to grasp. We've got our solder, which is just standard rosin core solder. Okay, we've got our soldering gun. You can also use a soldering iron. I like to use both. I mean, I can use both. The gun is just a little bit more accessible. I use the soldering iron mainly for more detailed stuff. We've got our trusty pair of wire snips, or sometimes the more professional term are dikes. We've got our tape. This is just regular electrical tape. You can get it in different colors. And then I've got the trusty helping hands right here, which you can get these at Harbor Freight for like $5. They're really, really handy, especially for holding small components while you're trying to solder. It's basically a third hand for soldering. Okay, so that's all of our tools. Again, we'll go over the tools again real fast. We've got helping hands, which is this. We've got our tweezers, which are here. We've got our wire cutters, solder, tape, soldering iron. Okay, and that's all we should need for this. And then for our ingredients list, one more time, we've got LEDs. They can be pre-wired or not pre-wired. I tend to like the pre-wired ones just because I don't have to worry about using more wire, and they come easily out of old computer front panels. We've got our wires here, which it's always a good idea to just kind of pre-cut and pre-skin the ends so that you don't have a whole lot of work to do there. We have our our locking switch to turn it off and on with. We have our 1 ohm resistor, and we have our battery, or battery pack. And I'll just show you a quick battery pack. This is just a AAA battery pack. That would be 4.5 volts because it's 3. Each one of those is a volt and a half each. But I like to use these because they're rechargeable and they're pretty much free for me. So let's go ahead and put solder the wires onto the battery. We're going to need to do that. I'll go ahead and get that out of the way. So I'm going to zoom in a little bit here. I'll go over how to get a hold of these kind of batteries at a later date. You can buy them on the internet. Of course, you know, when you have your own IT business, parts, scavengeable parts are not hard to come by at that point. So I'm going to go ahead and let's do the positive line first. Okay. So I just hold the trigger in on the gun to let it preheat a little bit. And then we put our solder down, or we put our soldering iron down, and then we put our solder in. And you're going to see it. When the top of the battery gets hot there, it's going to work its way right out to there. You take your finger off the trigger, keep the end there, and pull up gently, and it will cool down. And there we have our positive. There we have our positive in, nice and soldered, and see it's good and snug. It's not coming off. Now you can secure this, which we'll do. I'll use a little hot glue. Hot glue is the electronics, the home electronics builder's best friend for covering ends of these. Now, I don't want to completely cover it. In fact, yeah, I don't want to completely cover this because I'm going to be recharging these batteries. But if you're using a battery pack, you can go ahead and coat those ends with the hot glue, and that way you don't have to worry about them touching and shorting out. I'll use tape because, like I said, I want to be able to recharge this battery. So now we're going to go ahead and do our negative line. Try to get them in the same approximate position on the battery. Now let's go ahead and heat this up. Let off of the trigger, keep the end down, gently pull, and boom, look at that. Perfectly soldered wire right there. That's a happy little battery with some happy little wires. Doing the Bob Ross. Alright, now we'll go ahead and pull some tape off. We'll go ahead and cover those ends so that we don't have to worry about shorting out the battery. Doesn't take a lot of tape, just a little smidge. And we just cover the end just like that. I'm going to zoom back out again. Cover that end. Now let's move down to the next end. I like to try to get that tape nice and tight so that it's on there good. Okay, now we don't have any worries at this point about shorting those ends together. Now, you want to be careful if your lines are already pre-stripped. Don't touch them together. These batteries, these lithium-ion batteries, I do need to give you kind of a word of warning. They don't like heat, high heat very well, and if you short them out, they will catch on fire, okay? And they will burn, and they'll burn pretty bad, okay? So just keep that in mind. Nothing to really be worried about, just something to keep on your mind. And remember, don't short them out. Don't cross the streams, as they say on the Ghostbusters. All right, so now what we're going to do is we're going to go ahead and put our little resistor on the switch. Now, the way we want this to work, okay, we want the switch, we want the resistor going through the outside, or we would say, because it's only one side on a switch. When you hook a switch up, all you're doing is you're making a junction between one side of this positive line and another side of the positive line. Okay, so what we want to do is we want to put this resistor on the outbound side of this junction. Alright, so we go, I like to put it on right here, and then we pull this to the side like that, a little stem. Of course, I've got my, these aren't really polarity sensitive, resistors or not, but I just like to put the brown, I like to put the top band, the primary number band, to where the power's coming in, or where the voltage is coming in. So the brown is right there at the switch. So we're going to go ahead and just twist that around real nice, so it's nice and on there, and then we'll take our snips, and we'll snip off this little end right here. Very carefully, just snip it right off, just like that, so it looks really nice. Alright, now, of course, now we've got to solder that in place. So we use our helping hands again. And let me go ahead and zoom in so you guys can see that. And now be real careful when you preheat these switches, because they are plastic, they'll melt. You don't want to get it too hot. Melt the end out of it. Doesn't need much, just a little bit, just like that. And we're done. Now we have a nice soldered connection there. Okay. Alright, now let's go ahead and zoom back out. Alright, so there we've got our switch with our resistor in there. So we won't really need our second line. We can just go ahead and use this one right here. So we remember that orange and green, or yellow and green, are positive. Alright? So what we're going to do is we're going to take this, I'm going to take the end of the line, just the end of the wire, we're going to gently wrap it right around the resistor, just real gently. Electronics like it when you treat them gently. You know, it's not like steel armor. They don't like to be manhandled. You have to be real gentle, real patient, very patient with electronics. All right, now we're going to solder this. The key to a good solder is to remember that you're not really trying to heat the solder up. You're trying to heat up the wire and whatever it's attached to there, whatever you're trying to stick to the wire. You're not necessarily trying to heat up the solder. Because if you do, when you heat this up, the solder is going to flow right to the joint here. It's going to flow right to that little connection. Alright, so let's go ahead and snip this, and now we've got a nice clean connection. Alright, now the next thing we're going to do is we're going to solder this other line on, the other side, the other positive line. Let me go ahead and, sometimes it's nice to have, I like to have another pair of, it's just a pair of bull-nosed forceps pliers. I like to get this braided up nice and tight, because the tighter it is, the easier it's going to fit into these little tiny holes, if at all. Sometimes, in this case, I'm actually going to have to maybe clip a little bit off. Let's see. Nope, nope, it just does fit. Just does. We got a little straggler here, which we'll clip. And if you'll notice, we've not connected the other side of the battery up yet because I don't want to sit here and create a whole bunch of little sparks right there. It's not good for this type of battery. Alright. Let's get this back in the helping hands here. Turn it so you guys can see this as it's happening. There we go. And again, we just heat it up real gently. I like to kind of blow on it to get it to get that connection to set quickly. All right, now all we have left to do at this point is attach the negative side. The negative side of our battery needs to be attached here. So what we'll do, we're just going to do a little quick pretest. So I'm just going to kind of put these wires together here real quick. And then we're going to hit our switch. And I'm going to go ahead and pick these up and let's see what happens. Look at that. Green and orange. And they're pretty bright. I mean, they're fairly bright, but if you look at them apart, which one's brighter? It's this one. Okay? That's because it takes more voltage to light the green one than it does the orange one. So the orange one actually gets a little bit more voltage than this green one's getting, than the green one is pulling, I should say. Well, it doesn't pull voltage. The resistor is dropping voltage, but it's dropping around a volt. So this one is actually getting about 3.2 and change volts. And this is probably a 3-volt LED, so it's getting slightly more than what it should get, but it's not enough to really hurt it, but it does make it brighter. Whereas the green probably pulls right at 3.2 volts. So it's getting right about what it needs to be as bright as it is. So let's go ahead and... So you can always remember that. You can always apply just a little more voltage to an LED than it's asking for, but it's not much. I wouldn't try going more than maybe, 0.2 or 3, or yeah, 0.2 or 3 more than what the maximum forward voltage is. I wouldn't try going half a volt or more. I wouldn't try going a half a volt. That might be pushing it for some LEDs. Some can take it more than others. Alright, we're going to go ahead. We're going to solder this negative line together. Before we do that, let me zoom on down so you guys can see this. We don't need the helping hands anymore. Sometimes your tools make a good... they have ulterior uses. In this case, I'm using it as a weight to hold this down. So I'm going to go ahead and solder right here again. Remember, it doesn't take a lot of solder. You just need to make sure you heat up those ends appropriately, and you'll see when it looks nice. And in this case, yeah, it's pretty nice. It's a little globby. I'll tell you what, let's deglob this a little bit. There we go. Alright, so at this point, we're pretty much done with our soldering. And what we're going to do now, all these little joints that we made, let's zoom out. All these little joints that we have made while soldering, we really need to cover those with something. You can use hot glue, which is what I normally use hot glue just because it's much cheaper. But you can use tape. Now what I like to do is I like to lay this connection flat. See how that's nice and flat right there? I like to lay it flat. And there's no such thing as too much tape. You just want to get it on there fairly tight. So to make it, a little more, the tighter, the sturdier, the less stuff's going to get in there. You don't want stuff getting shorted out. That's never fun. And then have to spend time figuring out what you shorted out, or if you're using a lithium-ion battery, spending your time potentially putting out fires. That's never a good thing. This switch, believe it or not, is actually a lighted switch. I could have wired that 3 volts. I could have wired that 3 volts through the upper set of terminals on this switch and made the switch light up. Of course, I didn't want to do that. That's not, that's just, this is an example circuit. If this was something that I wanted people to see, or that I wanted lit for some sort of specific effect, I would do that. But I really don't, and I really don't think it's worth, losing a little more voltage just to have the switch light up when the rest of your project is going to be using that voltage. This is one more thing that's going to pull your voltage down and your current down quicker in your battery. So I just elect not to do it. You can do whatever you want. It's your circuit. You make it work your way. And again, we make it nice and tight. Alright, and now, there, we push the button. Our LEDs light up nice and bright. They're fairly bright. This is a great project for, if you need the LEDs in your Mandalorian gauntlets, or if you're working on another project, maybe a model or something like that, and you need some lights. This is a really good way to do it. Star Wars vehicles. It's a great way to make blaster lights for your Star Wars vehicles. I used to do that when I was when I was in my early 20s, and I had a bunch of. I've still got all my old Power of the Force toys, all those the vehicles and everything. I went and did this to a lot of the vehicles and made the computer screens light up inside of them. And my Millennium Falcon has, the little computer screens in the cockpit light up when you turn the Falcon on. And so there's a lot of different applications for these little things, but they work great. They come in so many different shapes. I'll show you real quick. This is my big drawer of LEDs. There's several different shapes they come in. Of course, you've got little tiny LEDs, really teeny. And then you've got there's Here we go. Nope. You've got square. You've got these little ones right here that are square. They're kind of made to fit through like a slot. And then you've also got, here's some square flat LEDs, and they're just perfectly flat. So there's all kinds of different LEDs. There's ultra bright LEDs. This is actually an ultraviolet LED. You can't really. This is what throws out ultraviolet light, so you can see in the dark. Of course, you've got different colors. You've got reds, and you've got yellows. Again, I would, if you're not sure what your voltage needs to be for your LED, super bright, or not super bright LEDs, but voltage. There's voltage calculators out there, voltage charts on Google. If you need a good place to get LEDs, if you can't scavenge them like I do, you can go to a website. It's called superbrightleds.com. That's where I get all of my specialty LEDs. I'll show you this circuit I built for another project that I'm working on. This is basically the same circuit that we just built, but it's compartmentalized for things like repairing and whatever. So you can, this is actually the LED. This is the type of LED that is in my energy axe. This is this is beyond an ultra bright. This is above. This is a 1000 millivolt or milliamp LED. It actually takes, it's a 1 watt LED. It's very bright, and I'll show you this shortly. But when I do my own circuits, I like to compartmentalize each part of the circuit in case I have to repair something. So see, you can pull the switch off, you can pull the LED off, and then what you're left with is just the battery and the lines feeding it. Now this one, I have attached this, which is a line I can plug in for recharging. So I can actually plug this in. I can plug the prop in without ever having to take the battery out. So it works out really nice. So let me put it all together. I'll show you how bright this is. Alright, and again, I've got another one of those locking switches. Now this is going to be bright. See how bright that is? That's insanely bright. That's what makes that nice blue glow in my energy axe. So it also works great for props like blasters. If you need a LED for your blaster, that'd be the perfect one to do, and you can rig it up to just like a momentary switch or something like that. So when every time you push it is when it comes on. But this LED was $12 and change. It was almost 13 bucks. It was like $12.50 or whatever. It's very expensive. It's a very, very expensive LED, so you want to be real careful when you wire that up. You don't want to burn that LED out or you're going to feel bad. But here we are. We'll put these LEDs together and I'll show you the difference in brightness here. Oh wow, yeah, you can barely, these two are still fairly bright, but really it's no competition. If you turn it over and look how well that illuminates compared to those. You put it over them, you can't even see those. So that's pretty much it. This is a very basic circuit. It's a great starter project, okay, for getting you started, for putting LEDs maybe in your gauntlets, or maybe LEDs in your helmet, something of that nature. It doesn't require a degree in electrical engineering by any means. You don't even have to scrounge for these batteries. You can just use conventional batteries in a pack. Just check your voltage. One thing that's a good thing to have, I'll show you this real quick. This is a digital multimeter. You can buy these at Harbor Freight Hardware for like $5, and if you're smart and you get the mailer or you go look for their coupons online, you can get these for free a lot of times. Just go buy like with any purchase, you can get it for free. So this is how I always check my batteries. Yep, this one's a little bit It's not bad. It might be a little low, but it's not bad. It's because we had it on. But these multimeters are very nice. They'll do DC, they'll do AC, they'll do they'll check your transistors. I mean, they'll do all kinds of stuff. So I would totally invest some money in, either buying one of these or buying something else. You know what? It'd be a perfect thing is if you downloaded the coupons, went and grabbed yourself a Helping Hands, and then got the multimeter for free. I mean, that's perfect. That's two of your main tools for your electronics bench that you can get for less than $10. So anyway, that's all I've got for today. Thanks for watching. This is Warmaster's Workshop. You can expect some more tutorials like this coming out in the coming weeks. So have fun armoring up, and I'll see you in the field.